spectral distance as a path difference. Okay, so the path difference between R1 and R2 is, so is from here to here and here to here are equivalent. Here to here and here to here are equivalent. Though the only difference is this part. Okay, so this part, how to get it? Okay, if this is D, then this is theta. Because if this is theta, then this is also theta, right? Trigonometry. Then this length will be d sine theta. So the path difference between these two reflected rays, R1, R2, will be 2d sine theta. Okay, what is the meaning of diffraction? Diffraction is the slight bending of wave as it passes around the edge of an object. If the opening is much larger than the light wavelength, the bonding will be almost unnoticeable. However, if the two are closer in size or equal, the amount of bending is considerable and easily seen with the naked eyes. Okay, so this is the reason why the wavelength of the X-ray have to be comparable with the atomic scale. If not, then no diffraction will happen. All right. So in 1913, the Bragg father and son, they found that the crystalline solid has remarkably characteristic pattern of reflected X-ray diffraction, X-ray radiation. That means when I shoot the X-ray to compound A, it's always produce the same pattern. When I shoot the X-ray on compound B, it will produce another type of the pattern. It's just like our fingerprint. All the compound or all the sample will have different diffraction pattern, just like you and me, we have different fingerprint. Okay, therefore they realize that, okay, if this is the case, then maybe we can make use of the fingerprint and to identify the structure. So from that time onward, they start to research on how to use the X-ray diffraction to study the structure of the crystal. So in crystalline material, for certain wavelength and incident direction, intense peak of scattered radiation were observed. This was observed because diffraction had happened. Okay, interference has happened. And why we mention the specific incident direction and wavelength? Because it's only happen when it's reached the Bragg law condition. Okay, the Bragg law condition is 2d sine theta must equal to n lambda. So when it reach the direction and it reach the wavelength condition, then the diffraction will be happen. So Bragg accounted for this by regarding a crystal as made out of parallel plane of atoms spaced by distantly apart. So they started to think of that, okay, actually the crystal is made out of many atoms, and the atoms are arranged in properly through many planes. Okay, before the Bragg law has been invented, no one know how the atom look like. What is the atom arrangement inside the solid? No one know, because we don't have the technology to know all these things. But after Bragg law, after Bragg father and son, they discovered that the X-ray can interact with the sample, and then it will produce a diffraction pattern. Then they start to think of that maybe the crystal is just built by many atoms that arranged in the plane. Okay, and the distance between plane and plane is d. So the condition for a sharp peak in the intensity of the scattered radiation were that the X-ray should be specularly reflected by the atom in one plane. So all the atoms on the same plane will produce the interference, and then the reflected ray from the successful plane interfere contractively. So all the atoms on the plane will produce the same interference, right? Then the interference plus another interference will get the interfere constructively. So it will double the interference so that you will get a very strong reflection or diffraction point. And at the same time, the path difference between the two X-ray is equal to 2d sine theta, as I showed you just now. So for the X-ray to interfere constructively, this difference must be an integer number of wavelength. So 2d sine theta must be equal to integer number of lambda. It cannot be 0.5 lambda. If 0.5 lambda, then the X-ray will not interfere constructively. So based on the Bragg law, we know that the constructive interference for refracted ray will only occur when 2d sine theta equal to n lambda has been fulfilled. So this is Bragg law, where n is an integer. So the integer n is known as the order of the corresponding reflection, or we call it order of interference. Constructive interference occur only for certain value of angle theta. And Bragg law is true when lambda is smaller or equal to 2d. So when lambda is too large, like visible light to 600 nanometer, that is its mass larger than 2d, then these visible light will not be useful for this Bragg law lah. So this is the interference. So like just now I say that the interference have to be constructive so that it will double the, okay, let's say you can see this one interact with this one, so it got the superposition. So this is the constructively interference. So you can see all the point and equal to 2.5 and equal to, these are all the constructive interference point. So the diffraction condition and reciprocal lattice, a crystal as composed of identical atoms placed at the lattice site T, and assume that each atom can re-radiate the incident radiation in all directions. Okay, and then sharp peaks are observed only in the direction and at the wavelength of which the X-rays scattered from all lattice points interfere constructively. So in order to observe the sharp peak, remember the diffraction pattern that got one, there are many reflection spots. In order to get the reflection spot, the direction and the wavelength of the X-ray must make sure that the lattice point will interfere constructively. Therefore, only certain and specific direction and wavelength can produce the constructive interference. That means the sharp peak. Okay, if it doesn't meet the requirement, then no reflection will be observed. Okay, so why direction and wavelength? Because 2d sine theta equal to n lambda. Direction correspond to this sine theta, then wavelength correspond to this one.